Solve 0 equals x cubed plus 9x squared plus 13x plus 5. So the first thing that we want to do is try to factor this, and we want to figure out what the roots are, because that's what it means to solve it. So just by the looks of it, it's not a quadratic. We can't use the quadratic equation. It looks like you can't really group it with anything. Like, there's aren't very many terms that you can, combine. Like 13 is a prime number. Grouping doesn't seem like the best method either. And the only other method that I could think of here is the integral zero theorem. So, if you can remember that, I hope I remember that right. Yeah, integral zero theorem. So, it means that we're going to think of the different possibilities of b, and we're basically going to figure out the factor by plugging in different values of x. So it's got a leading coefficient of 1, and it's going to be the b is going to be a factor of the constant term, which is 5. So it's going to be either plus or minus 1 or plus or minus 5. It's going to be one of these. So let's try with positive 1. So let's do f of positive 1. And that's going to equal 1 cubed, 9 1 squared, 13 1, plus 5. So this clearly is not going to, all of these are positive numbers, and we're all adding them. So we, just by looking at this, I'm not going to waste my time. This one's not going to equal 0 for sure. So let's try f of negative 1. That's our next one. Equals negative 1 cubed. Okay. F of negative 1 is equal to, and then I'm going to type this into my calculator because I'm lazy. So let's do negative 1 to the power of 3 plus 9. And then this is negative 1 squared plus 13 times negative 1 plus 5. Okay, this one does equal 0. So this one equals 0. So what does that mean? If our x value is equal to negative 1, then the factored form of it would be x plus 1 if I equal that to 0. So we know that x plus 1 is a factor of this one. So x plus 1 is a factor, but it's to degree 3. This is a polynomial function. So let me just really quickly graph this on my calculator, and hopefully this should be a bit more clear that we're not finished the question yet, right? So to the power of 3 plus 9x squared plus 13x plus 5. So now let's graph this. So there's one root. It looks like there's another root, and then if you were to zoom in on this, then I'm sure that would be another root. It looks like it crosses the x-axis. So it looks like there's maybe 3 roots to this one because it's a third degree function. So I believe it does cross 3 times, in fact. So x plus 1, so x equals negative 1 so one of our roots is negative 1. But there's 2 more that we could solve for. So yes, what we could do is solve for random other b values, but it could be an integer. It could not be an integer. It could be a fraction of some sort. It could be something, way too crazy and hard to find. So now what we're going to do, we're actually going to long divide, because since we know that x plus 1 is a factor, if we divide this by the function, then we're going to get the other factor, or at least a version of that might be able to be factored again. So let's do x plus 1. Hold on, let me change my colors really quick because we're doing a different part. So we'll do x plus 1. We know this is our factor. And we're dividing all of this by the function x cubed plus 9x squared. So remember the first thing, x goes into x cubed, x squared times x squared. Let's then subtract x squared times x is x cubed. X squared plus x squared times positive 1 is just x squared. Now I'm going to subtract these. This is going to cancel out. And then these ones are going to be 8x squared. Drop that down. So now x times what is 8x squared? That's going to be 8x. So this is going to be minus 8x squared. And then 8x times positive 1 is just 8x. And these are going to equal 0, so it cancels out. And this one's going to be 5x. And now plus 5, I'm going to drop that down. So x times 5 is going to be 5x. And then 5 times 1 is going to be 5. And then this is going to equal 0. And a quick way to know that you did this wrong is that if the remainder of this is not 0, then you know that this is not a factor. Because if it's a factor, it must equal 0, because that's what the remainder theorem tells us. You can tell if something's a factor if the remainder is 0. And this does in fact equal 0, so we are good to go. So x squared plus 8x plus 5, that's a factor as well. But what can we tell from that? Can we tell the roots from that? No, we've got an x squared in that. But what we could do is we could use the quadratic equation, or we could group it, or we could do whatever you want to figure out what the other factors are of that, or what the other roots are, sorry. So let's think of the easier stuff first. So what's going to add to positive 8, and what's going to multiply to 1 times 5 is 5. Well, we got 1 and 5, that's the only thing, and that's going to add up to 6, and that's the only thing. It's not going to add up to 8, so looks like I'm not going to be able to do that. But what I might be able to do is, well, first of all, let's see if we can actually factor this, and we know to see if we can, if this has 2 real roots, then it's going to, we can use the discriminant. D equals b squared minus 4ac. So if you can remember, if this is positive, if this is a positive number, then it means there's 2 real roots. If this is 0, there's 1 root. And if this is a negative number, that means that there's no roots. You can't solve that. So D equals, our b value is 8. So 64, because 8 squared, minus, and then 4, and then this is a 1. I'm just going to neglect the 1. And then C is going to be 5. So 64 minus 20, that's going to be 44. So this is a positive number, so there are 2 real roots. So it looks like the only thing that we're going to be able to do is use the quadratic equation. So don't get frightened, it's really not that hard. So let's, hold on, let me choose one more color here. So we've got, if you remember, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. All of it is over 2a. So x is going to be equal, b is 8, so it's going to be minus 8 plus or minus, and we already did the discriminant. I'm not going to waste time. This is 44 over 2a, and a is just a 1, so it's just going to be over 2. So let's think here. Root 44. Can that be simplified anyhow? Root 44. That could be, actually, I'm not going to use my calculator. I'm going to do this off to the side. So root 44, we can do, we can break that up into, hold on, let me write this out. That will equal, you could do 4 times 11, that will work. 4 times 11, and that will equal root 4 times root 11. And this is, remember, this is radicals, like simplifying roots. This is going to be 2 root 11. You could also write root 44 as 2 root 11. So x is going to be equal to negative 8 plus or minus 2 root 11 divided by 2. And it looks like these are, I've got a 2 on the outside of this, I've got an 8, and it's divided by 2, so I can actually simplify this to negative 4 plus root 11, or plus or minus root 11. Well, I'll just leave this as this one. This is one of the roots. And x equals negative 4 minus root 11 is going to be another one of our roots. So let's do like a final concluding statement. So we've got this root, we've got this root, and we've got our first root over here. So now we can just sum everything up that we learned, and we can say how we solved it. We can say what all of the roots are to this. So therefore, the roots of, and then I'm just going to assume that this is a function of f of x are x equals 1, or sorry, x equals -1, my bad. X equals -1, -4 plus root 11, and -4 minus root 11. So also, if I wanted to write this as an actual what's it called, like an actual function, sorry, then hold on, let me just do this over to the side over here, because we know that if this is our root, if x equals -4 plus root 11, and I want to equal this to 0, then I would just subtract the entire, or I'd add the entire thing to the other side. So x plus 4, this would be, yeah, this would be minus root 11 equals 0. So this would be one of the factors, and then the other factor would be, well, x equals -4 minus root 11. So if I change that and isolate it for 0, it would be x plus 4 plus root 11 equals 0. So this would be the way of writing it in factored form. Well, so technically, f of x would actually equal x plus 1, x plus 4 plus root 11, x plus 4 minus root 11. So this would be, this function is equivalent to this function right here. So now let's just double check with our learning that let's make sure that these are actually the correct roots, and we can use that by graphing it. So hold on, let me just quit out of this for a sec. First of all, no one's gonna know the number like off the top of their head, -4 plus root 11, like as a decimal. So let's just do that. -4 plus root 11. This is gonna be approximately -6.8. So we got -6.8, and let's do the same thing, second function entry, but let's do a minus root 11. That's our other root. So we got -6.8, and we got a -7, and then our other root is going to be -1. So if we go to the graph now, oops, wrong button. So let's do second function, calculate the zeros of this. So here's one. Actually, you know what? We're gonna actually zoom in as well, because this is very hard to see. So there we go. So now I'm going to try to find the root on this. So I'm going to do 0 here, and then a little bit to the left is right there. Then a little bit to the right is right there. So it's going to make an educated guess. So one of them is -1. That is correct. So now let's do another one, because there's three zeros to this one. So a left bound, let's say our left bound's right there. Then right bound a little bit to the right of it, another root is going to be there. So this should be about -6.8. Yeah, -6.8. So this one would be one of these roots. And then the last one should be -7.32. -7.32 should be the last one. So let's zoom out of this one. So there's the last root right there. So now we'll second function, and we'll calculate this last 0. Finally, go zoom all the way over to the left. There you go. There's the left bound, and then here is the right bound. So our guess, yep, -7.3166. and that is negative 7.3166. This is exactly the correct answer. So we indeed know that these are the roots of that function.